ahead and do with this then is we learned about imaginary numbers. Okay, so the first thing that you want to do is, do you guys remember how you deal with the square root of -4? When you're dealing with imaginary numbers, remember it goes like this. You can break that up into the square root of -1 times the square root of 4. And what's the square root of -1? I, that was I. What's the square root of 4? 2. So that's 2i. Okay, we talked about this last time. So what you would have here is you're going to change that square root of -4 to 2i. And you're going to change the second one to 2i like that. And then what's 2i times 2i? It's 4i to the second. Okay, you have to start the problem this way. And then there's always two basic things that you have to know. One of them is I is equal to square root of -1. And the other one is I squared is -1. Okay, all of the things about complex numbers are kind of built out of these two statements right here. So you got to remember that. Okay, so here's what you get for your final answer then. So what you do is you just say 4 times -1. So that means the answer of the problem is -4. Okay, all right. You have to do it in that order too. You can't do anything else. The one thing that you cannot do, and I see students do this all the time, we talked about this last time, you can't just put it under one radical. You're not allowed to do that, because if you did, you would get square root of 16, and square root of 16 is 4. So you cannot do it that way. You have to do it this way. Okay? Yes?
Did you get the -1 if I squared equals 1?
I squared is -1. Okay? So what I did is I just replaced the I squared with -1. Okay? That's where that negative comes from. Okay? So all these problems have to be started the same way. So number 18, what you have to do is you have to take that square root of -6, and you, first of all, you can do this in your head, but I'm going to go ahead and have you just write it like that. Okay, that's a good starting point. Same thing with the square root of -9. Write the square root of -9 as square root of -1 times the square root of 9, like that. Okay, so what you're going to get then is this. Okay, what is the square root of -1? You got to know that. So that's really I times the square root of 6. And this is also I times square root of 9 like that. Okay, now see, you can bypass that first step if you want to and just learn, okay, if I got a square root of a negative, just rewrite it that way. Square root of a negative, just rewrite it that way. You can go there immediately. Okay, now what's I times I?
I squared.
I squared, which is going to be what? -1. Okay, we'll do that later, okay? Now I'm going to go ahead and write the square root of 6. What's the square root of 3? Oh, I just told you. What's the square root of 9? I'm thinking ahead, right? Okay, so you got that. You could multiply that together and get square root of 54, but if you already see that you have a square root, you might as well just take that out. So now what we're going to have from here is -1, I squared is -1, that's square root of 6 times 3. So the answer, see, now you can do -1 times 3 and get -3 times the square root of 6 like that. Okay, so you're following. The key thing is, you got to remember what I is and what I squared is, and you have to do this in a certain order. Okay, this particular problem, again, do not do it this way. I'll say this one more time because I see students do this all the time. It is wrong to go through and just multiply those two numbers together and put under a radical, because you get a totally different answer. Okay, so you must do it the way that I'm showing you. Okay, all right, let's see. Let's move on and do a few other ones here. Okay. All right, now let me ask you a question on this and see if you guys know what I'm talking about or not. Okay, square root of 100, is that a real number or imaginary number? It's a real number, right? Because it's a square root of a positive. What is the square root of 100? 10. Okay, how about square root of -1? Is that real or imaginary? It's imaginary. What is it? It's I. So the answer to that problem is 10i. That's all you do on that one. Okay, you don't need to multiply them together. It's just I gave you an I and I gave you a square root of 100. That's it. Okay? Next problem, what kind of number is square root of 3? Real or imaginary? Real. Leave it alone. Okay, how about the square root of -125? Imaginary. So write it like this. Now, if you want to start bypassing that step, you can just say I times the square root of 125. That's the way you need to start doing this. If you see something like, for instance, square root of -3, just immediately write it that way. It's an imaginary number. Just write it that way. Okay, so now what we need to do is we need to kind of go back into what we've learned, And let's think about 125. Let's do a factor tree on 125. So I know that that divides by 5, right? 5 and 25 is going to give you 125, right? Now you can go further, but do you already know the square root of 25?
Yes.
Yeah, so you might as well just kind of break this up like this. Leave that square root of 3 alone. Can't do anything with it. Leave the I alone. And break up the square root of 125 into 25 times 5. The reason I do that is because I know what the square root of 25 is. If you took that factor tree further, I mean, you'd just have 5 to the third, and then we learned to break like an odd exponent up into the second power and then whatever's left over. So now what you'd have is this thing is going to become 5. All right, so what you're going to have for your answer then is you have the 5, the square root of 25 is 5, that's out of the radical. You have the I, that's there, and then you can put these back together. Okay, so that's 3 times 5, so it's 15. Well, I tell you what I saw when I was on the, let me pause this for a second here. It seems to be, yeah, okay, that is dim. I see that too. So, does that thing go off? You have to turn that off? Unless you guys want to see that for the rest of the day. Yeah. Okay, thank you. Okay, let's go ahead and let's do the division here.
That was 5i to the power is 15.
Yeah, okay. So the final answer on that last one was this. It was 5i times square root of 15. And again, what I did is, see, that's where the 5i is. Okay, we did the square root of 25, and that became 5. But then these things are under a radical, and they're both positive numbers, so you just multiply them back together. Okay, that's how you do that. Okay, next thing we're going to do, pretty similar. Okay, you want to start this by doing this. Okay, that's an imaginary number, right? So how do you write that? I times square root of 50. Go ahead and start that way. Don't start any other way. That's important. And then the bottom, how are you going to write that? I times square root of 10. Okay, you got to do it that way at the beginning. Now, it turns out that those i's will divide out. Okay, that's a 1. Anytime you have anything divided by itself, that is going to be 1. So now what you do is, since these are positive numbers, you can go ahead and put these under the same radical because they're real numbers now. So what you could do now is just 1 radical 50 over 10. Okay, and then what's 50 divided by 10? 5. Is there anything you can do with the square root of 5? No, because the factor tree just has a 1 and 5. It doesn't have 2 of something. There's no factor of 5 that can come out of that radical. So the final answer is square root of 5. Yes?
And the I is because they're negative?
It's just because, yeah, it's because there's a negative under the radical. They're imaginary numbers, so you want to start that way. And again, the thing on this that's important is you're kind of lucky on this problem. It's not correct to go through and do that. Okay, but it would end up giving you 5 anyway, so you'd be lucky. It's not really something you're supposed to do. You're supposed to start the problem like that. Okay, and let me go ahead and do this next one here. Then I'm going to let you guys just try the next 2 problems on your handout, and then I'll let him go to work here. So let me go ahead and get this here. Okay, so how do you start this one? What do you do at the numerator? I radical 48, and don't do anything different. How about the denominator? I radical 6. What happens to the i's? They cross out. That sounds weird. You cross out your i's. That sounds funny. Okay, so what you have is now you have 48 over 6, right? Now what's 48 divided by 6? 8. Okay, now if you did a factor tree for 8, is there anything you would find?
2 and 4.
Yeah, you'd find 2 times 4, so 4 is a perfect square. So you'd end up having square root of 4 times square root of 2. So that's going to give 2 radical 2. So that's your answer. Okay? All right, you guys go ahead and do 24 and 25. I'll shut this off. And then we'll see. How long does this take? Like 5 minutes? Okay, all right. Okay, go ahead and do that.
Well, a little bit. I got to let the lamp cool.
Oh, okay.
Can't touch it.
Okay, I'll touch it for you. Okay, I'm tough. While you're finishing them up, I'm just going to kind of take off the parentheses. Well, the first thing is you want to make sure that the only two that you got to change signs on are 33 and 35. So when I'm doing 33, notice I did change that to 9 minus I. Okay, and then the next one you have minus 6 minus I, so it's minus 6 plus I. That's it. Now the rest of it is how good can you do your arithmetic. Okay, so what do we have for 32?
11 plus 4i.
Okay, 11 plus 4i, good. Okay.
Exact problems from the last page. Like a couple
Are they exactly the same problem?
Two of them.
Well, they may be
Similar.
similar, I guess. Maybe some of them are the same. I don't know. All right, so the next one, you take the parentheses off. So what'd you get on this one?
15 plus 5i.
That sounds pretty familiar. Yeah. Okay. All right, 15 plus 5i. What'd you get for 34? Put the negative 5 first, okay, and then 8i minus 7i is, or no, 8i minus I is 7i. Okay. All right, we have that. Okay, and then the last one, what do you get on this?
0 minus 5.
Yeah, now you do have to put the 0. 6 minus 6 is 0, so you need to have that in there. And then negative 6 plus 1, of course, is minus 5, so you want to write the answer like that. Okay? On a test, I'm not too picky about not forgetting to do the 0, but technically that's what you're supposed to do if you're writing it in an A plus BI form. So that should be super easy. Now, what I see students do all the time is a lot of times students will FOIL this, which is what we're going to do next. If you have a plus sign in the middle, there's no multiplying going on. Foiling is going to look like this, right? You'd have to have something like 2 minus 3i and something else. Then you FOIL, which is what we're going to do next. But these are adding and subtracting. So just think of it as combining like terms. Okay, let's go to multiplying. So we've already learned that I squared is negative 1. That's a real big deal in this section. Okay, so we're just going to work some stuff out here. So this one we're just going to multiply 15 times 12. Let's see what that is. That's what? 5, what, 180? Yeah, so that's 180 I squared. You can use your calculator if you want to. Okay, can you tell me what the answer to the problem is in your head? Negative 180, right? Because what's I squared?
Oh.
Okay, so that's going to pop up over and over again now. So what we have is 180 times negative 1. Okay, now that's the real number part. So what you want to do is you want to write your answer as negative 180. There's not an I, is there? So you have to write 0i. Okay, if I want that answer in A plus BI form, you got to pay attention to that. So see, we got a real number. If there's no I in the result, then you got to write 0i. Okay, now the rest of these are going to be pretty similar to things you've learned how to do. So this one looks like a distributive property, doesn't it? That's exactly what you're going to do. So you're going to do 2i times 7 is 14i. Then you're going to do minus 2i times 2i is 4i to the second. That's stuff you've done all semester. Okay, what else can you do? I squared is negative 1. Okay, there is no like terms, right? You have an I and an I squared, so those are different terms. So the only thing you can do is bring down the 14i and then change that I squared to negative 1. Okay, whenever I squared pops up, you want to change that. Okay, so that's going to give you 14i, and then a negative times a negative is a positive, so that's 4. Now, the best way to write the answer is, since we're doing A plus BI, is put the 4 first, then the 14i second, like that. That's how you write your answer. Okay? So basically, it's stuff you already know how to do. The only thing different is the I squared, right? That's it. Okay, how about the next problem? Does that look like FOIL? It's the same thing. So you got two parentheses next to each other. If there was two parentheses with a plus in front, then you're adding. Okay, so this one's FOIL, so we're going to just go ahead and multiply that out. So if you do 24 times 4, I think that is 96. Okay, use your calculator if you need to. The outside term is 2 positive, so 24 times I is 24i, like that. The inside term, you have a negative times a positive, so that's negative 24i, right? And then the last term, you're doing negative times positive, so that's negative 6i to the second. Okay, just like FOIL. Does that look okay? All right, what do you see that happens? Those things cancel. They're like terms. The i's are like terms, so they cancel. What else could you do? I see that I squared, so what do? You replace it with -1. Okay, like that. That's what you typically do on these problems all the time. So you have 96 plus 6, which is 102. Okay? But again, I want the answer to be in A plus BI form, so can you tell me what the best answer would be? 102 plus 0i. There's not an I there, right? So you want to learn to write it in this form. Okay, when you get to doing homework on this, they're going to be pretty insistent that you do that, okay? All right, just to get it in that form as you're doing that then, okay? Okay, let's go to the next page here. Now let's take a look at this. Now, the way you want to do this is you want to write this out twice. This is the way I've typically been teaching you how to do this. Write it out twice and then multiply it out by the FOIL. And again, I squared will probably show up, so you're going to use the -1 for I squared. So go ahead, what you want to do is do the FOIL. So that first term, we have 5 times 5 is 25. The outside term is plus 45i. The inside term is another plus 45i. And then the last term is plus 81i to the second. Okay, so that shouldn't be a problem for anybody, hopefully. What do you do next? Got like terms, right? So these are like terms. Put that together. What else? I squared is -1. Okay, so that's what you do. You can do that all in one step if you want to. So that's 25 plus 90i. Those things are like terms, so they go together. You can start skipping a few steps in your head because that 81 is just going to change to -81, right? So what you have next is you have 25 plus 90i minus 81. What else can you do? Combine like terms, yes.
Why wouldn't it be 90i squared?
Because you're combining like terms. It's no different than having like 45x plus 45x. That's 90x. When do you get an I squared? When you multiply. So for instance, if you had 5x times 3x, that's 15x the second. Those are little things that's easy to forget about, but if you collect like terms, nothing changes. The I stays the same, just like the x would stay the same. Okay? All right, I'm going to have you guys go ahead and do the next 4 problems, and let's see how you do. I'll walk around and see if you're doing these right or not. Then we got one more kind of key thing to look at. So I think every one of these problems will have an I squared in it. And then again, just be sure you write the A plus BI form. So both things have to be accounted for. Okay, think you're on the right track. You see when you have I squared, you replace that with -1. So what you would say is 33 times -1. Ultimately, you worked out 33 times -1. First step, I squared is -1. Correct. Okay, that's good. Just write that as -33 plus 0. If there's not an I, be sure you put 0. Right. So then you're going to have negative 63 times negative 1 is going to be positive 64. And I think you're missing your I there, so that's 28I. You always put your final answer, you always put the I part last and the number first. A plus B. Yeah, those are canceled. Oh no, they won't on that one, I'm sorry. That would be negative 6I. Because you're combining negative 3 and negative 3 minus 3 is negative 6I. But this one will change to negative 1. So you're going to have 1 minus 6I plus 9 times negative 1. Because you're combining like terms. Okay, if you're multiplying, see, if you were doing that multiplication, that would be 9I squared. But you're not multiplying. You're collecting like terms. You're doing like minus 3 minus 3. So it's like $3 in debt, down 3 more is $6 in debt. Okay? Okay, that one should be negative 33, because remember I squared is negative 1. So when you replace I squared with negative 1, you have negative 33 plus 0.
But the original one was 32, but we see.
Exactly, it's because the I squared changed it to negative. Right? When I squared pops up, you use it changes the sign. Okay, that looks good. Then be sure to write that as negative 33 plus 0. Okay? Gotta have both things accounted for. Just add them together. Yep, absolutely. And then you would have a missing I, so you'd have a plus 0 I there. Okay? And see, what you're doing on that one is you're multiplying by what's called a conjugate. Okay, you're doing okay, except write that as negative 33 plus 0 I. Missing the I, put the 0. Okay, we're on the right track there. I don't know. I'm just trying to see if you're going about it the right way.
Okay, I'm not sure about
I
this.
think you are.
Did you just put the 0 in front since you already have the I?
Yeah, if something else is missing, if the real part's missing, you put a 0.
Okay. Thank you.
Okay.
Maybe.
Okay, so let's see if we did these right. Okay, so the first one, step 1, 33I squared. Second step, change the I squared to negative 1. So you should get negative 33, right? But then how do you write the final answer? Negative 33 plus 0I. Make sure you have both things accounted for, okay? The next one's like a distributive property. So you should start with 28I. That should be a part of your answer probably. And then this is going to be minus 63I squared, okay? Well, next step is change the I squared. Don't change the I. There isn't anything you can do with I. That's the imaginary unit. So you'd have minus 63 times negative 1. So what happens to that negative 63? It just changes to positive, right? That's what happens with the I squared. So you have 28I plus 63. But what's the correct order to write it in? Real number first, I second. So the best answer is 63 plus 28I. You always want to have it in that order. Okay, everybody okay? Okay. Next problem, these things are called conjugates, so you should have had a 0I in this problem. Because what happens when you FOIL this, the first term, 7 times 7 is 49. Okay, the outside term, you should have 7 times negative 5 is negative 35I. The inside term is positive 35I, so you see how those things are going to cancel out? That's because the signs were different in the problem. Then the last term is minus 25I to the second. So if you FOILed it correctly, that's what you should have. Then these will cross out. That's 49, right? Then you have 25 times negative 1, because that's what I squared is. All right, so what you would have from here is 49 plus 25. See, we don't have an I in there. So what's that, 74? Okay, so what's the answer?
74 plus 0I.
74 plus 0I. Okay, everybody got that okay? All right. And then the next one, what you should have done was just wrote it out twice. Okay, like this. Well, then multiply it out by FOIL. Okay, you're not going to have anything canceling on this one. The first term, 1 times 1 is 1. The outside term, you have 1 times negative 3 is negative 3i. The inside term, you get the same thing. That should be negative 3i. Then the last term, you have a negative times a negative is a positive 9i squared. So that's your FOIL. Okay? Do these things cross out? No, they combine to give what? Negative 6i. Okay, those are like terms. So write that as negative 6i. And then the I squared becomes negative 1, right? Okay, so what you get from here is you get 1 minus 6i minus 9. So what's the answer?
Negative 8.
Negative 8. Those go together, give negative 8. That's the real part. And then the minus 6i. That's what you should have got. Okay? That's pretty easy, isn't it? Okay, imaginary numbers are pretty easy. I mean, at this level, we're just introducing to the idea. Okay, the next thing we learn is a little more work. It's dividing. So in order to understand this, you got to understand the conjugate, which we certainly have talked about, and we've talked about rationalizing denominators. So that's actually what we do. If you look at this problem right here, this is what this problem really means. It just means 2 plus 3 times square root of negative 1, 3 plus 4 times square root of negative 1. What you guys learned how to do, if you have, two terms in the bottom separated by plus or minus, you learned the correct way to get rid of a radical in the denominator is multiplied by the conjugate. What was the conjugate? The same thing, except that sign's backwards. Okay? So what you would end up doing on this problem is you would multiply the top and bottom by 3 minus 4i. The point I'm trying to make on this page is you are rationalizing a denominator. Since that I is really a square root, you're getting rid of it. Now, I'm not going to finish this problem up, but I do want you to write this down. What you would do is just write down the problem, and then what you would do is you would multiply the top and bottom by the conjugate of the bottom, 3 minus 4i, and then 3 minus 4i. Now, I'm going to do several of these examples in just a minute, but what you're going to do is what you just got through doing. Doesn't that look like FOIL in the numerator? Yep. How about the denominator? That looks like more FOIL. So that's what it is. There's a little bit more work involved in the problem, but the idea is you're working with what we call a complex conjugate. Okay, that's the idea. Okay, now I'm not going to finish that because we're going to do that anyway here in just a minute. Okay, so let's go through and let me show you kind of what you would do on this one. I'm going to start by just writing the problem out. And again, what this problem means is it really means 2 over 5 times square root of negative 1. What we're really doing is rationalizing the denominator. So it turns out on this one, all you got to do is just multiply by I. Okay? No conjugate, because that term, that denominator just has a 5i in it. Okay? So if we do that and go straight across, we're going to have 2i, and then the denominator is 5i squared, right? Well, again, what's I squared? Negative 1. You're going to see that over and over and over again. So 2i, leave it alone. You can't do anything with an I. But you can change that denominator to this. Okay, so what that's going to give you is 2i over negative 5. Okay, like that. Now, what we do on this generally is, and we've talked about this before, generally you don't want a negative denominator, so you just bring that to the numerator to write it like that. And that's really an okay answer, but again, what they want is this a plus bi thing again. Okay, well, we got the I part, so I'm just going to write that as, we usually write that as 2/5 I. We don't have that real part, so we write it as 0. Okay, so that's how you got to do that. So what I'm doing, if you just have an I, but you don't have a sum or difference, like you do on 47, 48, just multiply by I. And that's no different than this. And let's see if you guys remember this or not. Like if I wanted you to rationalize the denominator on square root of 2, what did you do? Multiply by square root of 2 over square root of 2, right? That's, we're doing the same thing here. We're multiplying by I over I. And that gets rid of the radical. So if you finish this up, that would be square root of 2 over square root of 2 squared. So that would be root 2 over 2. Okay, you learned that in an earlier section, so we're doing the same thing. That's the point I'm trying to make. An I is a square root. Okay? All right, the next problem, what we do on this, let's go and just write that down as 9 over 2 minus 9i. Now what's different on this one is your denominator has 2 terms. Okay? So we got to multiply by the conjugate of the bottom. Okay? What's the conjugate of 2 minus 9i? 2 plus 9i. We call that a complex conjugate. Okay, you're going to talk a lot about this in college algebra and do a lot more with complex numbers in that class. So we're going to do top and bottom by that. Okay, if you remember to do that, the rest of it is FOIL things we've been doing that are not too bad. Okay, so let's go ahead and multiply out the numerator. So when I do that, I'm going to have 18 plus 81i. Okay, that's what we get there. Okay. Now, if I go to the denominator, I think you'll see the idea is we don't want to have an I in the denominator, just like we don't want to have a radical in the denominator. So if you FOIL this, you would have 2 times 2 is 4 for the first term. The outside term would be 2 times 9 or 18i, like that. Okay. Now, if you start looking at the inside term, look what happens. That's now negative 9 times 2 is negative 18i. So doesn't that cancel the i's out? That's why you did it. That's why the complex conjugate comes in handy. Then if you do the last term, you have negative 9 times 9 or negative 81, and I times I is I squared. But I squared is negative 1. So you're going to find that when you do this next step, you'll just have a number in the denominator. That's what we want. No i's, just a number. Okay, so let's push on and see what we got. That's going to cancel. Then what you're going to have is 18 plus 18, nope, not that, 18 plus 81i, like that. And then the denominator, you're going to have 4 minus 81 times negative 1. Now, you'll be able to do this in your head because this shows up all the time. What is that denominator going to be just in your head? 85, right? Because that's going to change to 81, right? 81 plus 4 is going to be 85. That's what happens on this. So now what you're going to have is 18 plus 81i all over 85. Does that make sense to everybody? Okay. Now there's one other thing that you want to do with this problem. Since we want to write this in the a plus bi form, what you do is you go ahead and write this as 18 over 85. You just split it into 2 parts, and then you also do plus 81 over 85i. Okay, you write those as fractions. That's the preferred way to do that. That way what you have is the A part is 18 over 85, the B part is 81 over 85. So when you get down to that step right there, just split it apart. The 18 over 85 and the 81 over 85. That's how you want to do that.
Oh, it's 85. Oh, 85.
Yeah. Okay, because what will happen when you multiply by the complex conjugate, the denominator will always just be a number. There will never be an I in the denominator. Okay, let's do one more of these, and then I'll let you do some, and then we'll take a break. Okay, 6 plus 7i, 7 minus 4i. Okay, tell me what the conjugate of the denominator is.
7 plus 4.
7 plus 4. It's always the denominator you're looking at. So what you want to do is multiply the top and bottom by that complex conjugate. Okay, so we want to do that to the top and bottom. Okay, then it becomes an exercise in foiling, which you guys did this fine a minute ago, so as long as you don't make any mistakes, you should be okay on this. So let's go ahead and wrap this up then. Okay, so I'm going to do the numerator. So 6 times 7 is 42. Just do the FOIL. 6 times 4 is 24i. Okay, the inside term is 7i times 7, 49i. So you got some like terms you can put together. Then the last term, 7i times 4i, is plus 28i to the second, like that. Okay? Now, what will happen on this, when you do the denominator, you can actually take a shortcut. I want to show you guys one thing visually. Okay? And once you're convinced of this, you can start taking a shortcut. Wouldn't that be negative 28i and 28i? So wouldn't they cancel? In fact, they always will. That's the reason why we're doing the conjugate. So if you want to start taking a shortcut, you can actually, instead of foiling it, you can just full it. Okay? Because that's what will happen. Okay? you're going to end up having that inner and outer canceling out. Now, I'm going to go ahead and do all 4 steps, but you can just do first and last and it'll work. So the first term is 49. 7 times 7 is 49. The outside term is plus 28i. The inside term is negative 28i. So like I said, they're going to cancel. Then the last term is negative 16i to the second like that. Okay? Now let's see what we can do on the problem then. So in the numerator, what do you spot in the numerator that you could do? You got like terms, and what else? You got I squared. Okay? That's what's always going to happen on these problems. So you have 42. If you do 49 plus 24, that's going to give 73. So that's plus 73i. And then you have 28 times negative 1, which is going to make that a minus 28. Now, once you get the hang of this, you can just skip that step and write minus 28. Okay? When you go to the bottom, what happens? That cancels, right? What else? I squared again. Okay, so that's going to be negative 1. So you're going to have 49 minus 16 times negative 1, right? Okay, now we got just a little bit more to do here. So I'm going to write one more step like this. The numerator is really 42 plus 73i. That's now minus 28. So that changes that sign. The denominator is really 49 plus 16. Okay, like that. So like I said, the denominator will never have an I in it, so it doesn't. So what we have, if we put this together, let's see, 49 and 16, if you add that together, gives, I think, 65. So you have 65 there. And then the numerator has like terms. So you can do 42 minus 28 to get 14, and then plus 73i like that. Okay? All right, so that's what we do. The details of that are not too hard. They're applying things that we've been doing. So the last thing I always want you to do on these problems is to just break it up into two parts. So how do we do that? We say 14 over 65, 73 over 65i. That's how I want you to write your answer. I like that. So at the very end, don't forget to do that. Okay, and the reason is because we want a, which is this, plus bi, which is that. Okay, yes.
On that last term, does it matter if the I is in the numerator of the fraction, or does it have to be kind of off by?
Well, the thing is, your answer is always going to have a plus bi. You will never end up with an I in the denominator. That's why we're doing the conjugate.
Yeah.
But you'll almost always end up with an I in the numerator. So you want to break up your real part and your imaginary part in that order. A plus bi.
Yeah.
Okay? All right, let's do a few problems. I'm going to just kind of set you up with what to do. This one, if it's just an I, you want to multiply that one by I over I. So I'll let you do that, and then I'll set you up. I'll start you off on number 50. What do you need to multiply number 50 by?
3 minus I.
3 minus I over 3 minus I. Okay, so go ahead and take it from there, and then I'll let you do one more. There's one more problem I want you to do on 51. I want you to do that one also. Okay. So just see if we can get all the details of the algebra done. Okay, then we'll take a break. Just be careful with the details. So this one, you would have 7i over 6i to the second. So that's 7i over 6 times negative 1. So that's 7i over negative 6. Okay, that's what you have. Now be sure you write the answer correctly. It's 0 minus 7 6i. And that 7 6 is just like right in front of an I. That's the standard way that you write that like that. Okay? All right, the next one, let's see. You do a distributive property. 9 times 3 is 27. 9 times I is minus 9i. Now the bottom, so you guys can start doing this if you want to. Just be careful about it. You can just say 3 times 3 is 9. And then I times negative I is negative I to the second. Because what you need to understand is, see, that 3i and minus 3i are going to cancel anyway, right? So you can jump to there and do that denominator that way if you want to, because of that cancellation, okay? So what you would have then, after that, you would have 27 minus 9i. Now this would be 9 minus negative 1, right? So what is the denominator? 10. That's 9 plus 1, so that's 10. So you'd have 27 minus 9i all over 10, then you just break it up. Okay, the first part is the 27 over 10. That's the real part. The second part is the minus 9 over 10i, so that's your answer. That's how you write it. Okay? All right, guys doing good. Everybody got it under control, you think? Okay? This stuff's usually not that bad to learn. Okay, let me finish up this next one here. So we're going to multiply by 2 minus 5i, the complex conjugate, over 2 minus 5i like that. So it's just a matter of foiling the top and foiling the bottom. So I want to see if you got that right then. Okay, so if you foil the top, you would have 18 minus 45i plus 18i, and then the last term would be minus 45i to the second. Okay, so that's what you should have for your FOIL. The bottom you can FOIL, or you can just do first and last. If you do 2 times 2, that's 4. The inner and outer cross out, then the last term would be minus 25i squared like that. Okay? All right? So what we'd have in the numerator is 18. These are like terms, so I think that's what, negative 27. So that's minus 27i. Again, there's your I squared. So that's going to be minus 45 times negative 1, like that. And then the bottom, the denominator, is going to be 4 minus 25 times negative 1. What you're going to start catching on to, if you haven't already caught on to it, what does that I squared really do to that 45?
Just change it.
Changes it to positive. Down there, didn't that just change that to plus? Okay, you can bypass that step, but you just got to be careful about that. So what you're going to have is the numerator, 18 minus 27i plus 45. Denominator is really 4 plus 25. So if you did everything correct, you would have got 29 in the denominator. And then the numerator, let's see, if you do 45 plus 18, what's that? 63. So you have that, okay? And then just remember to split it up. So your first part is 63 over 29. Now, if that fraction reduced, you would obviously want to reduce it, but it doesn't. And then the second part is this. So you'd say minus 27 over 29i like that. That's your answer. Okay, that's it. Okay, you guys did good. I didn't see too many problems. What do you think? Okay, all right, let's go ahead and let's do a break till 15 after. I'm going to show you how to do powers of I. I'm going to do this pretty quickly. I'm not going to spend a whole lot of time on this, but we already know that I is just square root of negative 1, right? And we know I squared is negative 1. So what we're going to do is we're going to raise these to the power. Now I'm just going to show you how I figure these out, okay? You'll deal with this maybe a little bit in college algebra, somewhat. So when you do I to the third, remember, everything is built off of these two statements. So I'm going to write I to the third as I to the squared times I to the first, right? Okay, well, I to the second is what? Negative 1. So we're just going to leave that I alone like that. So if we do negative 1 times I, we actually get negative I. So what I to the third is negative I. Now we're going to do a pattern. I'm going to show you kind of a trick for figuring these out in a minute. But I want to show you the methodology for doing this, okay? Now I go to I to the fourth. Okay, what I'm going to do is, remember, all it takes is to know what I squared and I is. So we could also write this as I to the second times I to the second. You could also write it as I to the third times I to the first. It doesn't matter. So tell me what I squared is.
Negative 1.
Negative 1. So wouldn't this problem just be negative 1 times negative 1, right? Which is what? 1. So I to the fourth is 1. Okay, like that. So to me, all I ever remember is the first two, but I can figure out the rest if I need to. Okay, now I'm going to go on and just kind of do the next ones. And I'm going to do each one a little bit differently. So I to the fifth, I'm just going to do I to the fourth times the I to the first left over. Okay, I'm breaking it up. Okay, what did we say I to the fourth was? 1. So that's 1 times I, so that's I. Okay, so that just takes you back to I. Okay, and I'm going to keep going, and you're going to start seeing a pattern on this when we go through this. Now I'm going to do I to the sixth. What I'm going to do is I'm going to break it up again into I to the fourth. Why? Because I to the fourth is 1. 1 is easy. It's an easy number to calculate with. So I do this. I just break that up like that. 4 plus 2 is 6, right? What did we find I to the fourth to be?
1.
1. what do we know I squared is?
-1.
-1. So 1 times -1 is -1. Okay, it looks like we're starting to repeat ourselves. We got a -1, -1. Let's see if the next one's -I. Let's find out. So if I do I to the 7th, again, I'm going to break this up into the I to the 4th and what? I to the 3rd, good. I to the 4th is 1. I to the 3rd we already found to be -I, so you're going to get -I. Okay, so what happens on these things is they kind of rotate in groups of 4, so the next one predictably would be what? It'd be 1. Okay, all it is I'll go ahead and do that, but I to the 8th is really I to the 4th times I to the 4th, and then that's just 1 times 1, so it's equal to 1. So these things go in patterns of 4 forever, infinitely. So the idea is if you're doing a power of I, you're either going to get I, -1, -I, or 1. Okay, these things are kind of conjugates too, -1 and 1, I and -I. Okay, so they have a plus and minus on them. So that's the pattern. So what I'm going to show you how to do on these problems is I'm going to show you how you could, a way that you could do this. Let's take I to the 7th. Okay, and this is the simplest way to teach you how to do this. Kind of a trick. What you can do is just always take that exponent and always divide it by 4. Okay, so if we do 7 divided by 4, that goes in 1 time with a remainder of 3. So it turns out, since the remainder is 3, then all we got to do is I to the 3rd. And I to the 3rd, if you look up at the chart here, turned out to be -I. Okay, so that's just -I. So if you know what those first 4 are, then all you got to do is figure out the remainder when you divide by 4. And it'll always work out. Okay, does that make any sense? Okay, no? Okay, I'll work a little more out because I'm basically on this just sort of showing you a trick for now. Okay, so now we're going to do I to the 48th. Here's what you do. Just take the exponent and divide by 4. That's what we're going to do on every single one of these problems from now on. Over and over again, divide by 4. Now I'm going to write this little chart here. If you have a remainder of, it goes like this. If you have a remainder of 1, you might want to write this chart out. This might help you a little bit. So this is the remainder. Okay, like this. If the remainder is 1, the answer is I to the 1st. If the remainder is 2, the answer is I to the 2nd, which is -1. If the remainder is 3, then you end up with I to the 3rd, which is -I. Now, you're never going to end up with a remainder of 4, but you will end up with a remainder of 0, and if that's the case, then you just get 1, like that. That's how it goes, okay? Without going through a lot of the theory behind this, I just want to get you comfortable with how to do this. So if I do 48 divided by 4, that'll go in 12 times. It has a remainder of 0. Okay, so what the answer is since the remainder is 0, answer is 1. That's it. Okay, like that. Okay, the reasoning for this is because of this. You could write I to the 48th as I to the 4th to the 12th power. Okay, because after all, what do you do with the exponents in that kind of a problem? Multiply. 4 times 12 is 48, and I to the 4th is 1. Okay, so what you end up getting is you end up getting 1 to the 12th, so you get 1. That's why this remainder works. You don't have to do that last step. Just use that chart if you want to. Okay, so the next one's going to go like this. This goes in 7 times, and there's 2 left over. So if the remainder is 2, what's the answer? Look at my chart. -1. Problem done. That's it. Okay, because that's just I squared. The reason for this is basically this. You can write I to the 30th, and here's how I'm doing this. 7 times 4 is 28. So what I'm doing is I'm writing this as I to the 4th to the 7th with I to the 2nd left over. Now you got to think about what's going on. Isn't that just I to the 28th? Right? Okay, what's that? That's the remainder. That's what you're doing. So what's I to the 4th? I to the 4th is 1. So what's 1 to the 7th? 1. 1 times I squared is I squared, and I squared is -1. That's the y part. I don't think you have to understand that at this level of class that much, but if you just kind of use this chart, you'll always get it right as long as you're dividing correctly. Okay, let me do one more here. So let's see, 29 divided by 4. That goes in 7 times again, okay? But this time the remainder is going to be 1. So if you have a remainder of 1, the answer is just going to be I. Okay, so the answer is I. Like that. That's it. That's all you got to do. Divide by 4 because these things go in groups of 4, and that's it. Okay? All right, and that's all I'll show you on that. I'm not going to spend a lot of time on that. I do want to show one more thing. A lot of you have graphing calculators. So this is kind of a nice thing to show students at this level of the class, is if you have a graphing calculator and brought it with you, look at your decimal point. Now this would be like a TI 83, 84, basically that. If you have a decimal place, you probably see an I there. Is that right? Okay, so if you want to try this, you can do this. What you have to do is you got to go second decimal point, and then an I will come out. And then you can go raise to, let's do the problem we just did, the 29th power. So you can actually do it like that. Look at that, I comes out, okay? That's pretty cool. You can also do stuff like this. If you wanted to learn how to multiply complex numbers, try this. Let's just say we have 2 plus 3i. And again, you're opening up that I by just doing second of that decimal point. Then you could put in like a set of parentheses, and let's say 3 minus 9i, like that. Okay, so you can actually multiply complex numbers on a TI calculator. Now if you press enter, how cool is that? That would be the answer after you FOIL and do all the stuff I taught you today. So that's pretty cool. It works. Okay, so you can do a power of anything on there. Every now and then it'll give you a weird answer, but if I did I to the 5th, for instance, it's I. Okay, so any type of a TI calculator should have that button on there. So that might come in handy if you're doing some homework and stuff. I want you to do it by hand, but you can check. You might as well learn how to do that now. That's a pretty good thing to look at.